Welcome to Module 2 of our tour around the Belmont Forum's Data and Digital Object Management Plan, DDOMP. And in this module, we're going to prepare you for some of the open science practices involved. I'm Alison Specht, and I've been working with Shelley Stall in the Parsec project funded by the Belmont Forum, which itself was supported by FAPESP in Brazil, JST in Japan, ANR in France, and the NSF in the USA. We ourselves are funded, in the case of Shelley, by the American Geophysical Union, and me by the Terrestrial Ecosystem Research Network, an ecological observatory, and I'm based at the University of Queensland. Now, before I start, I'd like to acknowledge the traditional owners and custodians of the land and sea in all nations. We honour their profound connections to land, water, biodiversity, and culture, and pay our respects to their elders, past, present, and emerging. Now, in every one of these modules, we have been using this scenario of your project workflow in a Belmont Forum project. You will presumably have, if you're listening to this, have developed a pre-proposal. If you were successful in that, you would have been invited to prepare a full proposal. For each of those, you will have a version of the DDOMP. If you're lucky enough to be awarded, you'll be entering now into your annual to multi-year project, in which you will do your work, your primary research work that will achieve the goals that you wish to achieve. In this process, you will be supported by having a good DDOMP, which will cover things like your activity records, help you make decisions about your communication modes and remind you of what you'd planned, help you create an effective shared working space. We're assuming that if you're Belmont Forum funded, you'll have a distributed team of some sort, physically distributed. So a shared working space is a really critical decision. And of course, will take you out to the end of the project. Of course, the thing that really matters to researchers and to the Belmont Forum is what you produce from your work. Your output, your conference presentations, through papers, through data and code publication, etc. In all of those circumstances, you will be supported by your DDOMP, and a link to the elements of the DDOMP is included below and will appear in every module. So do have a look at that. Now, in order to help you a little to envisage what is involved, we have posted an example of our DDOMP, which is in fact a proper output. We'll talk more about that later, as illustration. And we will refer to relevant operating principles which relate to the Belmont principles as we go along. And there is the link to that. We've got version 4 up there now, and a description of how it was built by us can be found also in a paper published in the Data Science Journal, which you may find interesting and helpful as an accompaniment to this talk, to these modules. Now, I'm planning to cover today, or in this module, is the Belmont Forum Open Data Policy. You've been introduced to it already, but how it applies to your team. The FAIR data principles, team organisation and responsibilities to help you succeed, data management principles for your team, and strategies for preserving your project. And we have quite a few of these items summarised in a handy checklist in the publication attached, linked here. Open Science Practices for Teams Prepare. So the goal of this guideline that is supporting this module is that we are providing material to help you prepare for your work and to be successful in your work. So do have a look at that as we go along and for the future. So first, the Belmont Forum Open Data Policy and how it applies to your team. Now, the Belmont Forum Open Data Policy is, of course, applicable to digital objects as well. And there are 4 major planks and objectives that they wish the data and digital objects to comply with. One is to be discoverable through catalogues and search engines. Another is to be accessible as open data by default. So hopefully not too much protected data, and made available with minimum time delay, so in a timely manner. Understandable in a way that allows researchers, including those outside the discipline of origin, to use them. Manageable and protected from loss for future use in sustainable, trustworthy repositories. And you can see just below that cell a link to Lin et al., who describe what a trusted repository is and should be. And I exhort you to have a look at that if you're in any doubt. Now, how your team can respond. How does this, therefore, apply to your team? Well, to make it discoverable through catalogues and search engines, you just need to think about our social media world, our world of discovering and buying and things through the internet, of discovering information, our news feeds. All of those require a standardized vocabulary or mapping to a relatively standardized vocabulary that a machine can use to enable the discovery that you want. I want a new fridge magnet. Where will I get a fridge magnet? So you put up fridge magnet, buy. That's a controlled vocabulary of some sort, somewhat recognized by a machine. When it comes to research data, I'm sure many of you know this, and research descriptions, the vocabularies that you use can be rather confined to your discipline, and of course may indeed be confined to, historically at least, to your country or domain of concern. For example, I'd use soil scientists. Now, soil description back in the day, we're talking 1950s in particular, we had a description of soil types and detailed description that was particular to the United States of America. A different description of often the same soils in Russia, a different description in ex-colonial countries like Australia, no doubt Canada, that was linked to the UK, etc. Now, they were often the same soils. Not always, but often. And they were described differently. There was the great soil groups, there was all sorts of other schema that were used to describe those soils. And if you were in the USA and you went to Russia or you went to Australia, you were puzzled by and had to learn any commonalities, etc. Now, they were community approved because the soil science societies in each country had worked out this schema, worked out the names, the description related to color and texture, all sorts of things. Now we're in the digital world, the same thing happens, but we now are much more multinational, or uninational if you multinational. We have to smooth and map some of these things. We don't want to lose information, but we need to be reasonably systematic in how we use a vocabulary. Some people quite clearly use a vocabulary that's particularly related to a department of a government or a laboratory, of a research laboratory, and it's unique to that laboratory. How can that become open data unless there's a translation mechanism? So the best thing is to try and map yourself, your data descriptions, to a broader community-approved control vocabulary, hopefully international, but maybe at least country, so that when that little research bot can go and find your data from some other country, your data can be easily discoverable. And of course, describing the vocabulary is very important. So describing what you mean by this term, can aid the mapping, the cross-mapping across disciplines, across domains, and across nationalities. Now, that's the first one. So second, accessible. You can discover the data, but it's not necessarily just accessible. And accessible means putting your data in what's called an open repository, if you can. Now, quite a lot of your data for human information, human data reasons, for ethical reasons, for economic reasons, for rarity reasons, may be sensitive. If you've got a rare plant, or a beautiful rose or a beautiful orchid, there's one found in this scene behind me, you don't want everyone knowing exactly where to find it because it will quickly be extinct. So that sort of sensitive information, as well as information about people, about disease, you can't publish all of that data. And anonymizing it is difficult, but as much as possible, publish things openly and promptly publish. COVID has given us a good reason, a good example for why we might publish promptly, because it was only through open sharing of data between laboratories and vaccine developers in a rapid fashion that the vaccines were able to be developed as quickly, in record time almost, as they were. There are many other examples. One of the big reasons is if you publish quickly, then you'll remember all the things you should have attached to it, the licenses, the descriptions, much more easily. So for your own convenience, publish quickly, as quickly as you can. Publishing 20 years down the track, you've probably got to redo the data, you've got to describe it again because things have changed, and you've probably forgotten a lot. So publish quickly. Understandable. Make sure you have comprehensive, precise descriptions of your data. How many times have I heard, oh, yes, I've got my data, I understand it. And you look at it, and I have some on my computer, and the person says, I'll read this paper. It's got a vague description of the data in it. You look at the data, the person has used their own idiosyncratic terms. No, where's that community-controlled vocabulary? And hasn't described the methods properly, which machine they used, which version of a satellite image, of a satellite feed they used, or whatever, well enough. So for others to use, and the forgettery if it's not published promptly. So there are some real aids to this, namely some standard schema to remind you, oh yeah, you've got to don't forget to describe this, and don't forget to say this and explain to others, because when you're doing the work, you often forget that some of the information is not available to others. It's in your head. So it's a classic problem, but it is common. And so we've listed a few discipline-specific schema that might help you describe your data well for it to be reusable. Finally, of course, is the trusted repository. And in fact, a really core trust seal. If you read Lynn, you'll hear some of the discipline-based repositories now the World Data System has picked up are given accreditation as a core trust seal repository. Turns is one of those, we're very proud to say. And they will help you do all of the above. use proper vocabulary, choose your degree of openness, and also describe properly. But also they are given that accreditation or known to be a trusted repository because they have some longevity. Now, nothing is ever forever. We know that, unfortunately, but there's probably a succession plan in place. What will you do to, if it's going to be there for the long term, and or if it folds, there's a management practice for preserving the data elsewhere, so it's forever in perpetuity. So that's the value of a trusted repository, to help you and also to make sure your data continue to be available. Through thick and thin, changes in technology and in code, internet access code, it's quite a big deal to be a trusted repository. Now, Lin et al. Will help, but Stall et al. Did a rather nice table back in 2023, which uses a comparative system to look at generalist repositories that are not discipline-based, but they're generalist. And the questions they ask, the measures they ask to compare, will be informative in themselves. So that's a good example that you might look at and use, may even help you, but also read Lin. Okay, some work to do. Now, the next thing is the FAIR data principles. Now, the FAIR data principles are, well, delightful. They have organized a lot of things people were talking about over quite a few years about how data could be more useful. If you're going to publish data, what do you have to do? What would make it useful, valuable, and secure for other people to find? And Wilkinson et al. Back in 2016, I think we'll have the link to that later, have written a paper which encapsulates lots of those ideas into 4 basic principles: findable, accessible, interoperable, and reusable. So in these modules, by the way, you'll see a lot of words and concepts used repeatedly in slightly different contexts, but I think reiteration can be useful and hopefully make things more understandable rather than confusing. Okay, so we will be understandable, won't we? So basically, findable will allow the aim of this, of FAIR, and you'll hear it bandied about, is to aid the discovery and reuse of digital resources. So they're not just plonked up there, but people can actually find them and can reuse them. And anyone involved in research, in the research data lifecycle, would find this important from the point of view of using other people's data, be it meteorological data, climate data, or producing their own. Okay? And of course, the other thing you'll remember from this module in particular, but all of them, is the mantra: as open as possible, as closed as necessary. So this will not be the first time you hear, the only time you hear this in this module. So FAIR and the DDOMP does serve as a guiding framework to follow. So you can see it comes into the planning of research, collecting data. Now, many of you in the Belmont Forum projects will not be designing a new research project, but you can imagine doing that and applying FAIR right at the basis of going out in the field in collecting data, doing a survey, going into the lab and setting up your hypotheses and that sort of thing. You can bring FAIR into that. If you're in Belmont, you may well be using existing data, and then you'll be looking at the data that you collect and seeing if it has fits FAIR criteria. And if it doesn't, that can be a good indication right off the bat of whether it is reusable for your project before you even have to mess with it and spend hours or days working out why you can't use it. So FAIR is very important. And of course, if you follow that data research workflow that Anu Devalu did, led a paper about in 2021, you can see that FAIR comes in all sorts of areas of the data life cycle. And of course, ensuring in particular your data sets are as fair as possible. Now in Parsec, we, Janeth Machikow et al. Published a paper about reproducibility, which is the other component of FAIR that I often get mixed up with, reusable or reproducible, but reproducible with respect to code in particular, or reproducible in respect to methods, of course, to see if your method is true. And we could easily swap R for reuse and reproducible. It means something different, but it's actually a nice test. And Machikow et al. Have a nice example of how to do a desktop test of whether something is reproducible, code is reproducible, which saves you a lot of bother. And I mentioned the repository, particularly if you have a trusted repository. It may not as yet have Core Trust Seal accreditation or may not be appropriate for it, but a trusted repository that fulfills most of those objectives can be really good, because shared responsibility, there can be some very helpful responsibility between the repository and the data creator. The repository, it serves them to make sure the data they have in their repository is fair, okay, as much as it can be. So they can often help you a great deal in guiding you through this process. We will not go backwards. We'll go forwards. Okay, so the next topic that I will talk about is team organization and responsibilities to help you succeed. And this may seem somewhat peripheral to a data and digital object management plan or output, but in fact it's integral, foundational, quite frankly, almost as much as FAIR data principles are, if not more, particularly for teams. So working openly as a team, what does this mean? There are many aspects to helping your research team work well. So your team, again, if you're in a Belmont Forum project pipeline, you will probably have designed a project that requires quite a bit of diversity, inherent diversity. It may be sort of skill set diversity and experiential diversity, which is shown in the upper circle shown here, this one here. Or it could be a more kind of demographic diversity shown in the bottom circle. Now, whatever, you will end up with differences, barriers, and barriers, differences and barriers that may be small or may be large. And however small or large, they may impede the good research and analytical process. They may impede sharing and most particularly trust within the team. Now, you really do need to build up a good trust space for your team so that they will collaborate to produce the aims we all want. Most of them will have joined the project because they subscribe to the goals your project will have. That doesn't mean they have the same perception of those goals. They may have a different understanding of their role than you, perhaps as a leader or as a colleague, understand they're supposed to be doing. So actually, it's a fair bit of time can be spent, it needs to be spent defining project goals, making sure everything's in place. But just to cover here some of the points I've got shown in this slide. You may well have just to explain a little bit more about the nature of the barriers or non-communication that may occur. So if we look at the top one, this is probably partly a depiction of the sorts of people you might want or skill sets you might want. You might have in your project some research scientists. And they may come from different origins, hence the colour, or different genders, different career stages, different disciplines. You may have the same, I've got technicians both in black, but they will also have differences that are related to country, organisation and gender, and they have a different background, way of thinking, a different way of approaching the world from each other due to all those demographic differences, but also research paradigms. If you're an experimentalist, you will tend to understand controls, reference sites, references, compare, contrast. You're going to set up an experiment that way, then you will analyze the results. That's very different from a remote sensor, for example, or from a modeler. Some of these people won't see the whole project per se. They'll be there for some particular component of the project. They may generally understand the project, hopefully they do, but they mainly only see their component. Of course, then you've got this agency scientists, what I call agency. They're often government-based scientists, if you're lucky, or they could be operatives, managers and policymakers from agencies, from government, whatever it might be. And they often have a very different sense of objective and outcome from a research scientist. And they may also have a very different language, way of speaking. They may not be open. They may only speak agency speak. And you have to get the team to really understand this in both directions to get the best out of it. And of course, we usually ask for a postdoc or early career researcher to be in a team. And why do we do this? Because they're actually often up with the latest in R. They're often used as a dog's body for a project. They're often employed by a project. So that makes them the continuity that in many of these projects, you dip in, and most of the team members dip in and dip out as they have time. And this will come back earlier. They're not all employed. These research projects, they're not like projects in a workplace where everyone is employed by the organisation or whatever, or the government or whatever it might be. Most of these research projects, people are coming of their own volition and pitching in to a common goal. And that must be remembered. Now, noting the postdoc and having talked to them a lot of the time, dog's body, multi-purpose person, meant to be the glue that keeps the project together. They, however, do not have the experience and understanding that the experienced or mature researcher does. So having a combination of both, and note career stage, can be a real benefit to the project. Now, one of the things that I suppose is fundamental to innovation and creativity is to have barriers and boundaries, is to have different perspectives. So you don't want to pull back because you think, oh no, this is going to be too difficult. We'll have to have bridge builders, we'll have that sort of thing. If you do that, you may well diminish your outcomes. The originality and the creativity of your outcomes. So there's a challenge, but there's also a benefit in having these different things. Now, a lot of these different components that I've got on this slide are mandated and will be mandated by your organisation, by the funder. But they're also, for representativeness because of their funding priorities. But they're also very much part of what can make things happen. You want wisdom as well as new ideas. So, talking about some of these expectations in a little bit more detail, I've got 4 4 different topics that I'll cover, and the first will be team formation, expectations and conduct, and I've gone too hard. Okay, team formation, expectations and conduct. Now, this first one, your team members, first bullet point, it may be mandated, as I mentioned, quite a lot of it. So, often in some countries, a certain gender, 3 or at least gender balance needs to be in, and it's been well established through innovation, creativity, ways of thinking. That's a very good thing. If you've got a multinational project, it's important to have different backgrounds from country of origin, but also if you may want some Indigenous inputs, for example, or depending on your topic, you may want different ethnicities involved. Experience, I mentioned, the wisdom of the person who's been through the mill. Spatial, of course, scientific discipline, career stage, just different words for the same thing to some extent. One of the things that often is forgotten is, have you members with strengths in bridge building, record keeping, communication and leadership? And we'll expand on this in a minute. But that's, the way a team works. And often when you create a research project, you forget about these other values. People in one particular discipline may have great skills in bridge building. I'm not saying you have to have additional people, but look for those skills in your team. The other thing in making sure expectations are clear, particularly if you have a long project, it's often important, and I say long, it may be 3 years, 2 to 3 years and more, particularly if it's voluntary, where people have their own job and they join the project because they're interested in the goals. It's important to keep the standards of the team behavior in people's minds and have them well established, a bit like it's part of the DDOMP, at least we've added to it, because it's part of the foundation. Your Code of Open Science practice will record the appropriate community, national and international standards, the EU standard for research code, best research practice, whatever is important for your country, relevant to the research, different from human subjects research to satellite research to research on biota that don't speak, and ensures intellectual property rights of the team members are respected and applicable licenses identified. Now, licensing will come back later with respect to data and digital objects, but we're talking about the team members themselves and the conditions in which they come. Now, like the mantra, open as possible, that we will repeat here, the saying, you want to get to a point with your team that whatever happens in the room stays in the room. So when you start, and you're not in a room most of the time, you're over in different parts of the world, different buildings, different agencies, and different types of employment. You need to ensure for your team that whatever they bring to the table for the teamwork is protected while the teamwork happens, and no one will take some data that's shared in confidence with the team and publish it elsewhere without anyone knowing. There may be an opportunity, I could help you publish this, and that may happen, that's an agreement. But it is not unknown for people to use these situations as an opportunity to pinch other people's information, intellectual property or data or whatever. It is rare, but it's not unknown. And In some countries, these codes of open science practice are novel. In others, they've been proved to be really useful. So explain what it's trying to do, make sure you've got in it what you need, and get everyone to sign. Now, we've got an example on page 16 of our Parsec DDOMP of how we designed ours, and we kept the records in a safe place. Okay, then the next bit is how to work collaboratively. Working collaboratively, there's a whole discipline in team science, just noting that research projects are different in many ways from much of that wonderful research, and it is wonderful research, and I'm only touching on a bit of it here, in that these research teams are mostly volunteers. They're not paid to do this work. They propose, they'll help solve a question, that's why they're given the money, and their employer has let them participate in it, but if it doesn't work, you know, to some extent it doesn't matter. So you really need to make sure they feel the team will work, that they have a role in the team, that they like or at least know the positives and negatives of their fellow team members, in order to have the important discussions that you need to have and to share the data and information that you need to do. And I could have put different disciplines and countries and organizations and at the end of that first bullet point. So you need those, and if we have face-to-face meetings, one of the examples of what we do in synthesis centres, for example, is we put aside time, an afternoon, say, to have a social adventure, to go somewhere, to walk somewhere, to go to a museum, to not artificially play a game. You don't want to do that team building sort of thing, so obviously with research teams, but you need to enable the research team to understand that this is a valuable opportunity and is a valuable component. Working remotely, you can do other things. There are things you can do to get people to begin to relate to their team members, not as an anonymous person, because many of these teams that are created, only 30% of the team members will know anyone else. That can commonly happen, and some will know no one else. You know, there's 3 people might know everybody. So you've got to build the relationships as well as maintain the relationships during the project. And that requires a bit of decision-making, a bit of action. Working transparently is very important. You don't want to have someone thinking that they're being locked out, even if they've got a discipline that isn't needed at the moment, or is on one's, you know, you'll have subgroups that are experts at this and that and have to fulfill some component. If that happens for some time, people can often become, forget why that is. You don't have a reporting back. You need to be as transparent as you can to enable people to look and check, maybe not involve themselves and be a pest, but keep an eye and, you know, make sure that things are as much as possible shared openly within the team. Now, this is not normally considered, I would venture to say, not normally considered part of a DDOMP, which is all about outputs. But unless you do this properly, you won't get to the outputs. You won't get that paper. You won't be able to get the U-Butte amalgamated harmonized data set or that big analysis. Okay, so it's really important to do this. And we're suggesting that you have, of course, along with meeting notes, progress reports, establish a digital object registry and make sure you have a shared storage space that people, and shared is the key word, that people can get to. We'll talk a bit more about that in a minute. And of course, have to work openly. So work out a way in which all team members can participate and be included in the various aspects of the project work Again, I mentioned there will be subgroups depending on skill sets and that sort of thing. But I mean, it can benefit both parties. Sometimes the subgroup can hit a wall in their work, and by someone else looking in, they could say, oh, yeah, I might know someone who could help with that, even though they were not considered part of that subgroup and could, generally keep out of this. It's surprising how often that can be a beneficial thing. Of course. Now, one of the things that you will probably, researchers are pretty good at, they assemble a team according to their skill sets, their knowledge of data. You've got the mature person, the experienced researcher, you've got the young person who's really good at R or Python and cracking something or other. But the mature person goes where all the bodies are buried. No, where all the good oil is. But you also need to think about some other team tasks that I mentioned. So you need someone who can support the DDOMP, can maintain communication across the team. Quality checks. Not everyone can do this. If you can find 1 or 2 people for each of these tasks, they will happen. And it can shift over the project time. Someone who quality checks. That's quite important. Someone who is trusted, particularly if it's, one country doing something and they don't want to share or check, if they can be persuaded to have someone who's also skilled in that area, but to look at their country data, to quality check it, can really make a difference, because sometimes something doesn't quite mesh, and this person from another area may find, for another geographical space, might have a solution that their country found to this country's immediate challenge. Someone to manage archives and preservation procedures, including past the project end date, because papers are still being written, things like that. You're going to have someone, a couple of people who other team members can contact and say, hey, I've just got this paper accepted. Hopefully you don't hear that because you want the data deposited or the code deposited beforehand. But, it's still 1 to 2 years. Reviews take time. And a couple who manage reporting, because Belmont wants to know, the funders want to know, rightly, how things are going. And they've got particular fields, so there's some things like that. And of course, if you do a DDOMP, don't assume that your best laid plans will be upset. There's no problem with that. Don't assume everything remains the same. It won't. Check in regularly. Check in regularly for updates and improvements. Reassign responsibilities according to changes in the circumstances or the abilities of team members to continue with the responsibility A, B, C, D, or E that you have above, or their research responsibilities. Invite all interested members to review processes and outputs, and there are ways to do that, which we might talk about. Okay, finally, these are the ways to do it. Team communication practices. Big point number 1, establish a regular point of contact and set times for meetings and discussions. This could be via Zoom, Teams, whatever, but they're going to be on, and this takes a bit of negotiation, this date, this time, every 2 weeks, every 3 weeks, everyone's going to get together, and there will be an opportunity to share progress, to report, hey, this subject. You see, that may be where it stops, but to say, oh, like I've hit this wall, that's the opportunity. It's also the opportunity to say, how's your, do some social discussion as well, which fits that other criteria, fulfills that other criteria of building a bond. What's it like at night in country X when I'm in the early morning? Things like that. Is it very cold? I want to hear about it. Doing that as well can really help build bridges. But it is also the opportunity, and I suppose mainly one might say, for saying, how is this component of the project working? and they can do a little show and tell or not. It can just be a discussion. So that's really important. Everyone is not necessarily able to attend every meeting, but that doesn't matter. The fact that it's there, that they know if they can, it's on. And the person who arranges it has to bite the bullet and say, oh, well, 6 of them didn't turn up. How can I make them come next time? Is there something missing, or is it just that they're busy? If the group is multilingual, conduct meetings using both discussion and text. We can, of course, use automated translation tools, but of course they need editing, definitely need editing. So having good meeting notes, listening to the recording afterwards, so it's always good to record, and then cutting out the bits about what's the temperature like in your place that I mentioned earlier, because that's not the bit you put in the meeting notes. Okay, but it will be in the automatic translation. Having a lead of the meeting, taking responsibility for making sure the meeting notes take account of all the important items in the meeting. So, running a meeting 101, but making sure there is time, because not everyone will understand, and different ways of catching up with what is said, because not everyone will pick up what I say straight away. As one might speak too fast, one might use an idiomatic term that is unique to my country and no one else understands. Anyway, allow sufficient time for common understanding of the work and the role of each team member to develop. I think time becomes, in the next 2, 3, and 4 here, time is very important. Time is not wasted. I mentioned earlier that time needs to be put aside to build trust and knowledge of your team members, and from that will gradually, hopefully, when they produce what they're supposed to produce and they do what they say they'll do, trust will develop. And that requires time. It is not wasted time. Neither is time wasted making sure everyone understands where we're going, where you're going, and where you fit in, where the person fits in to the team. It may need, or certainly will need, revisiting throughout the project. Don't hesitate, because people go off and may see some particular aspect. Maybe they can bring everyone into that aspect, but you need to keep that cohesion together to get to your goal. I mentioned number 4 earlier. And part of that is expressing gratitude for what, I don't know that the grammar's right there, for what each member can contribute. Some members will appear to be slacking, maybe not producing what they said they did in the time. Maybe they're not contributing. You might, as the lead, this might be the role of the person who's thinking of the communication, or the leader. Remember those lists, to check in with that person, to find out what's happening. Is there something unsatisfactory about the procedure? Is there something happening in their lives that you can't change, that we will just need to back off a bit and wait until they can contribute? Is there something we need to change to enable them to feel they belong? Or maybe we have to say goodbye to them. But you don't want an unhappy, angry person because they're neglected. So not everyone can contribute all the time. It's very important to know what they can contribute needs to be properly acknowledged, and they need to be thanked and appreciated for that. Equally well, maybe it is an ill fit, and that can happen too. Okay, now I'd like you to take a pause and look at these next 2 activities and think about them. So, and I will proceed the recording, but you can pause and pick up on that. So here we are. You've got a team, I presume. Match your team members according to their personal qualities. So here we have your people. You've got some people who are, and this is a classic team building thing from way back, people who are very good at working in teams. Have you got someone like that who can really help pull the team together? You've got some people who are great at coordinating timelines and making sure data is arrived on time. Specialists who are particularly good at Python or whatever, you need to deal with them. You need to know who they are. Now, you might have them down as doing the person who's the good team worker may in fact be one of your specialists. They may overlap, I doubt it. But anyway, it could be one of your specialists. These aren't necessarily unique to a person, but having mapped in both ways their skill set, their research expertise, their knowledge, the pile of data they may be bringing to the project, they may be really good at monitoring and evaluating or analysing or having great ideas. Remember, you want to have some innovative thinking. You want to know, okay, I want to have this ideas person really engaged in this exercise. So see if you can use this table here to think about the tasks your team members might help with. So, and think about their attributes. You might like to expand them to add more. Implementers, completer, ideas person. And remember that ideas person isn't necessarily a team worker, but they may put a spanner in the works and make people think, may be useful, whereas the evaluator or monitor might just be watching how things are going. And you really do need a completer. So you need someone who's going to make sure you're not just talking, you're actually producing. That's a really interesting task. So you may want to add more, but on the left of this table here, I have the DDOMP tasks. And think about your team members and who you might suggest or nominate against these tasks to help you. Now, the team leader will probably have to do a lot of reporting, bad luck, but have someone else help you with that. So, and where's the data and digital object management plan? Who's going to do that? It needs to be done every now and then, checked, updated as you learn things about your project. Now, I'll leave you to pause with that and come back after you've thought about these things, and we will proceed with the recording and with data management principles for your team. So I'm just going to pause the recording for a moment. Oh, no, I won't. I could record the recording for a moment, but I don't trust it. Data management principles for your team. Okay, so you're beginning to think to the end, about the end. A lot of what we're talking about is how to get to the end using your DDOMP as a guide. But you've got this, you've got to have the vision of where you're going to arrive. So how will you share your digital objects during and after the project? So be flexible. You want everyone in the team to be able to access the objects, but you've got to watch that sort of encouragement you may have to share objects in the project may not be automatically transferred to the public world. So, and also make sure that some of your work is definitely open to feedback and improvements. Track and manage information on digital object licensing. So I mentioned the licensing for the code of conduct. That is different from this licensing, but you need the same sort of thing for any data, software, and digital objects that you use are compliant with their license and any data transfer agreements. Make sure you keep an eye on that. And of course, for sensitive data, you need to consult at least your organisations, and it's probably got to come down to an organisation as opposed to Belmont. And it may be indeed your parent organisation, in my case, the University of Queensland with TERN. to go and consult with the ethics committee. I might have to get ethics approval if I'm interviewing people before I can do it, or else I cannot publish it. So you have to have that completed. In the US, it's called an institutional review board. Usually there's an exchange between such organizations globally. So if you're doing anything with human subjects, one approval will usually do. One country's approval will usually do. Check that. You may have to get 2 approvals. If you are dealing with sensitive data with rare species, that's, for example, that's another matter. So the ethics committee and the IRB can help you with that. So there are different levels, human research ethics versus other research ethics. So quite important. Economic research ethics, don't forget that, can be quite important. So we've got some of this in, quite a bit of it, in our operating principle 10, in our example DDOMP. So I've got the link there. Digital object security. Now, as I mentioned, it's very important to be as transparent as possible within the team, to make sure it's all transparent, everyone can see everything if they wish. Most of the time they won't want to wish, but they need to know they can if they want to, so that they will trust the procedure. So, for example, within the project, working spaces, minimum protocols, team communications, minimal protocols, group contact approach, working materials, protected by login. Now, someone can give a login away, but you've got that code of practice, and people should abide with that and not give logins to someone else, because many people don't want, and it can get down to careers can be ruined by unfinished working files being shared externally with someone who everyone doesn't know about. If you want to bring someone into the meeting, make sure the team knows before you do, or into the discussions, not meeting necessarily. Make sure the whole team approves before you do, and equally do not pinch stuff and share it outside. But these are not trivial things to make a decision on. You can see some of our decisions that we made in our Parsec project on the right. Now, of course, after the project, as open as possible, as closed as necessary, and for data, use a Core Trust Seal certified repository and allow CC by 4 access. Very important. That means the attribution is there. You will want attribution for your shared products. Increasingly, you should have a DOI for each one, and it will benefit you. So you should do the same for the people whose data or code you are using. You would do it with references in a paper. We must ensure that those same principles are applied here. And of course, publication should be open access. Make sure that's in your costs. Remember, after the project finishes, make sure, reviewers, you may have a paper submitted 2 weeks or even 6 months before the project finishes formally, but the article takes 18 months to get out in press. And then you're socked with an open access fee. So, you've got to think about that as well. Check on Parsec DDOMP 2 for guidelines there. Okay, finally, we're looking at strategies for preserving your project, and I have a little pause for you. Here, to do this, after we've gone through this, have a little break and see if you can reflect upon your project, whether it's got any sensitive or protected data, which one are most important to preserve, of course, are any particularly big. That's important for images, particularly satellite images, modified satellite images that you want to share. That may affect the choice of your repository. Do some need to be explained better? And of course, what type of files are most important? So if you pause now, you can pick up as I continue to the next stage of the module, the final stage of this module. So a bit more, how much of this is you've solved already by your reflection over the previous activity, or how much might have been helpful to your reflection. So I'm going to go through each of these items about the documentation, accessibility, and preservation of your digital objects created or used by the team. So record any conditions of use of existing digital objects. So if you're going to actually use something, and this may include, I mentioned climatic data earlier, in some countries that seems ubiquitous, anyone can get it. Of course, if you want retrospective data, you often have to pay, but that's another matter. You may have to capture the storms as you go live, but anyway, if you're doing extreme events, similarly with oceans and that sort of thing. But particularly with attributions for moving events, versioning can be very, very important. So ensure that attribution and versioning is recorded for any files that you review or use. And this digital object registry is really important and a great help. It may seem tedious at the time, but at the end, it can be very important. A short benefit is that if any member of your team, remember this is distributed around the world, if any member of your team happens to look at some data or code and apply the Machikow et al. 2023 comparison for code, a desktop comparison, they look at it and they decide using that desktop comparison that it is not reusable or reproducible. And they should put it in this digital object registry to say, look, we looked at this and it wasn't useful. They might actually put in why, which would be good. We'll mention that in a minute. But it will save other members in other parts of the globe who weren't there at the time, were trying to do it 2 days later. Oh, they've tried it. It wasn't useful. We won't go down that rabbit hole. Very useful. Same thing with data. Oh, we couldn't interpret the data. It looked fantastic, but the metadata wasn't there. We couldn't understand what these terms were. They didn't record the instrument. We therefore can't use it. And saying that saves your other team members a great deal of time. You can email them if you like, just to say, oh, I'll put it up here. But if you actually use them, this is the time to put it in the registry, what the permissions were, who the contact person were, whatever, and the version of the material that you accessed. Because often, for example, you're doing a code, you use a code, you've got the permission of the owner is forever updating the code, you publish a paper that was a fork from code version 3. If you didn't know it was code version 3, someone reusing your stuff might say, oh, it's that this person almost, rewrote your code entirely in version 5. So that's quite an important thing. So don't forget to version. This one we talk about a bit, but you've got to think about why you're wanting to preserve things and what the criteria are. And somewhat unrelated to that is the backing up your files during your project. Just make sure there's a backup. Make sure there's a backup. Even grand organizations have a hissy fit one day and go black. Not often. And often they have an excellent backup, as I have found when I lost everything in a particular shared folder and nearly died. Luckily, I had kind of backed it up, but I also contacted them and they had backed up the shared space. which was really good. And so it saved our bacon, and we produced a paper. And we're able to deposit the data and the methods. So make sure you back it up. But that's a really important criteria for preservation, right? You're preserving within the project, you're backing up. That's what it is. Okay, so during the project, it's about making sure you got it, you don't lose it. After it, it will be depending on the production that you want. This is the long term. So this is where your activity might have already told us. You're going to have data sets. You're going to have blended data sets. You're going to have new data sets from your experiment, your observations. Or maybe you'll have software. Maybe you'll have models. So your mode of sharing will be different, remember. Images. Special repositories are available for images. Often they're too big. Remember that question? They're too big to go in certain repositories, but there are other repositories that are able to handle them. Maybe you can zip them. Maybe that's acceptable. Maybe you want something different. And don't forget outputs that are transitory, unrefereed, but can be very valuable, particularly if you have a transdisciplinary project. You may need to demonstrate for your funders that you have communicated, that you have done what you said you wanted to do in training, like this particular module. We didn't say we'd do this. This is an extension of the Parsec project, but we did have some training within our project. We got feedback from people to improve things, and you can see, if you really want to, you could diagnose our conference presentations and see how they evolve over time as a result of that feedback. Now, as I mentioned, you will have, right at the beginning, you will have some things that are easy, open digital objects. We recommend CC by 4, so even if they're open, they're attributed. They've got attribution. You may have embargoes. You may have, you can share this until X happens. The repositories can usually handle that. Managed or mitigated access to digital objects, a little bit harder, but may indeed be the case. Beware the email contact, where, contact this person via this email to get access to the data, and the person changes their email and it's not updated, didn't tell the repository, for example. The person dies, the person retires, is no longer interested. The stories I could tell. Just watch that one. It's almost too burdensome, but sometimes it has to happen. And of course, you may never be able to release it. And that's the way it is. Sorry, we're going back here. And finally, to track and preserve digital objects, your digital object registry. So that's one of the key core bits during a project and used for reporting. And we'll show you how this can go for reporting later. Your digital object registry should include the details of which objects are preserved and when that preservation will occur and with whom. Is it going on to Zenodo? Will you be putting it into a trusted repository? Which repository? So if you fall over, the person who's doing it, someone else can come in and say, okay, I can do that now. I can action it. Include in your digital object registry some more detail, the metadata. And if you've published it, make sure you've got the citation. And this is absolutely vital for Belmont Forum reporting, by the way. They want to know, obviously, what you have published along the way, where they can find it, that it is findable. That was part of their open science mandate, their objectives. And if you can't get a DOI for various reasons, I mean, that does happen, provide a URL, knowing the risk that, again, URLs can disappear, websites can disappear. which is their pseudo repositories. And of course, the digital object registry becomes an important output. So it's not a bad thing to have. It is a kind of a guideline to where you can go to find things that may be easier to search for than other ways. Okay, so that's the end of Module 2. I think we've done quite a bit here. And next module is about learning things that will hopefully enable you to work through some of these procedures to equip your team to best manage your digital objects. And I would like to say thank you. And before I do, I will show you this kind of wonderful page, and you've probably got one of these, of the levels of the organizations that we are supported by in some shape or form, or that we've collaborated with. And you will probably have such a map. And you can see that in certain circumstances, in all circumstances, we attribute the primary funders, which you saw on our front slide. But in other circumstances, depending on the author of something, depending on sub-funding that we may have got, partnerships, collaborations in order to produce an output or a product, we will have to refer to any one of these in our project, in the Parsec project. So keeping that digital object registry, keeping a tab on who is really helpful, and who's connected to who. And of course, in Belmont Forum reporting, I think you usually have to have the URLs and organizational details, the RAWs, but more of that later, of each of these collaborators. So thank you very much, and we'll see you next time. Thank you, and I will stop the recording. Right.